Welcome to the next tutorial on electricity. Here we will be discussing about the flow of electric current, but before that let us recap what we have learned so far. We have already understood what is potential difference. We have already learned what is current flow. In this tutorial we are going to discuss how the flow of current depends on the potential difference. Then we are going to discuss what is the relationship between them, and then finally we will be discussing what is Ohm's law. Then we will derive a relationship between current flow and resistance when the potential difference remains unchanged, and we will try to get a concept of what is resistance and discuss about the unit of resistance. But before anything, let us try to get the concept of current flow. Now let us again bring this topic about flow of water. When two vessels they are connected and there is a difference in level of water between these two connecting vessels A and B, we will always see a flow of water from the higher level to the lower level. Now in the vessel in the column A, I have drawn 4 levels of water. First level is L1. That means that difference in level between A and B is L1, because in the B also there is a water. So difference in level is L1. Then if I add more water to the second level, the difference in level is L2. If I add more water, bring it to the third level, the difference in level is L3. You can see L1, L2, L3, L4 on the right hand side of the diagram, and then finally L4. Now as water level difference, the difference in water level increases between A and B, the rate of flow of water also will increase. But remember one thing here, the connecting pipe, the thickness of the connecting pipe should remain the same. If the thickness of connecting pipe is different, then it will alter the flow of water. Likewise, consider two charged bodies 1 and 2. The charged body 1 has more electron, the charged body 2 has very few electrons. So we will see a flow of electron from 1 to 2. Now as I increase the concentration of electron into charged body 1 from diagram A to diagram B to diagram C, as you see I am adding more and more electrons into the charged body 1, but in the charged body 2 the amount of electron is remaining the same. There will be an increase in flow of electron from 1 to 2, that means from the left hand side to the right hand side. So as the difference in electron concentration increases, the rate of flow of electron also will increase. Now this concept should be very clear into our mind. The flow of electron will increase as the concentration of electron increases. Now this concentration of electron we can call it as or difference in concentration of electron we can call it as a difference in potential or potential difference. Now we are going to discuss how the flow of current is dependent on this potential difference. Now let us think that let us denote potential difference by the letter V. Let us not worry about the unit of V right now, because we are trying to get the concept here. And let us denote the flow of electron, that means rate of flow of electron, by the letter I. And you are already familiar with this I and V from the earlier tutorials. Then now we will try to establish some relation between V and I. Now again, as in the case of water, as the difference in level increases, likewise in the case of current flow, if V, that is the difference in electron concentration, which we call as a potential difference, if V increases, then rate of current flow I will also increase. In a similar manner, if V decreases, I, that is rate of flow of electrons or rate of flow of current, will also decrease. So that means when V increases, I increases, V decreases, I decreases, and they decrease in such a particular way that ratio of V by I, that means if you divide V by I, it will remain the value will always remain the same. And we express this kind of relationship by a proportion symbol. We call V is directly proportional to I. That alpha sign that you see, that is the symbol for directly proportional. So we say V is directly proportional to I, and we can also write it in the other way, I is directly proportional to V. If V increases, I increases. Likewise, if I increases, V will also increase. So we can say I is directly proportional to V, and there is a reason for writing this way. Now what we will do with this sign of proportion? We cannot do much with this sign of proportion. We know only how to deal with equal signs. Now here I is the current flow, V is the potential difference, and I is directly proportional to V in such a way that if we divide I by the value of V, then always this ratio will be constant, and we can replace this sign of alpha, that is sign of proportion, using a constant and an equal sign. So what we will do is, we will replace this sign of proportion, that is alpha. Remember, if I increases, V increases, if I decreases, V decreases. That is the reason we use this sign of proportion. So we will replace this sign of proportion by a constant, because I by V is always remains unaltered. We call it a constant. So we can write this equation in this way: I equal to R multiplied by V, where the letter R is a constant. We call it as a constant. That means something whose value does not change, provided